Rajith is the CEO and founder of Randoli. Randoli, thank you. He's got several years of experience helping organizations adopt Kubernetes and build platform engineering solutions. He spent 11 years at Red Hat in engineering and consulting roles, and is a frequent speaker, even did the Red Hat Summit, DevOps Days, and Apache Con. So please welcome Rajith.
Hey, yeah, thank you. All right, how's everybody doing? Good? Okay, looks like I'm the last speaker for tonight. It's always great to be in Vancouver, beautiful city, the ocean and the mountains. We don't get that in Toronto. I actually came from Toronto today in the morning, and very excited to be here and meet all of you and have a discussion. All right, cool. So yeah, my name is Rajith. I'm the CTO and co-founder for Randoli. And today I just want to talk about building production-grade clusters for EKS. This actually came about based on our own experience. Let me see if I can, by working with customers out there and learning from those experiences, as well as our own running our own production clusters for our product. Let me see if this works. There you go. Yes. Yeah, and thanks, Warren, for the shout out today. Based on our experience working with Kubernetes and the customers, we ended up building a product around providing troubleshooting, cost optimization, and securing workloads. And we are very focused on Kubernetes. And as Warren mentioned, we try to take all the data and help people to troubleshoot faster. So that's very similar to the concept he explained. All right, okay, let's get started. All right, so before we get here, I want to, just a show of hands, how many of you have heard about Kubernetes or familiar with Kubernetes? I said, oh, it's quite a few, good. How many of you are running Kubernetes clusters in production? Nice, very good. And how many of you are using EKS? Awesome, all right. So I'd love to hear your thoughts, even after the talk. If there's anything you want to add, if there's any questions you have. I always learn something when I go and speak at conferences. That's one of the reasons why I do it, because every production environment is different, and there are some brilliant things that I've learned by talking to our customers and at conferences. So, all right, so let's move on. Okay, I want to focus on sort of three things here. High availability, recoverability, and cost consideration. Now, I should, have a slide or two about security as well, but given the time constraints and it's also not really my area of expertise, I am going to, just limit it to this. But if you do have any questions about security, feel free to ask. I'll, answer to the best of my ability. And if there's anything I'm, not sure of, I can get back to you later on. All right, so let's get started. And when we talk about high availability, we'll start here. It's a good place to start. It's kind of like the reference architecture. Now, if you're using AWS, you are familiar with the concept of availability zones, right? Right. So what you would want to do is, ideally, and we'll talk about alternatives in a second, you want to put your cluster across 3 availability zones. Now, if you notice here, I'm only just talking about the sort of like the data plane, the nodes, because AWS EKS is responsible for managing the control plane. So when you get to Kubernetes, there's sort of like 2 things, right? You have the control plane, and then you have the data plane, and the control plane is responsible for keeping the cluster up and running and the coordination of all of that, scheduling of your pods and all of that. AWS provides that as a managed service. So that takes care of providing you a highly available control plane. It's up to you to build. That's why it's a shared responsibility model, to keep your data plane highly available and up and running. So by default, if you create an EKS cluster, it's usually on a single availability zone. So you have to explicitly configure with a Terraform script or otherwise to say, put it on 3 availability zones. What it does is it will spread your nodes on these 3 availability zones, and that insulates your workloads from an outage in a particular availability zone. Now, just because we do this, does that mean that your applications are highly available or not? Not really, because by default, the Kubernetes scheduler will just schedule it based on availability and other things. So you have to explicitly tell the scheduler that you want to spread some of your important workloads across. So for example, if you're running like a Kafka broker on top of your Kubernetes cluster, you ideally want to spread your brokers across your availability zones, right? So you generally want to run like a 3 to 5 nodes type of broker topology. And ideally, you want each Kafka broker on a availability zone. So what that will give you is that in case there is an issue with the availability zone, you have reliability for the messages, right? Because with Kafka, let's say you're doing a replication factor of 2, right? So Kafka provides a reliability by replicating, not by just writing it to disk. So if your replication factor is 2 and you had 2 brokers that happen to be on a single availability zone and that goes offline for some reason, now you've lost some of your messages, right? But by placing it across 3 availability zones, you increase your reliability and high availability of the brokers. Now, to do that, you have to do something called the topology spread constraints. And so essentially, in your spec, I've just used a very simple example there. You just tell it to use the topology key, which is going to be a label. So if you create like a EKS cluster, you will see there will be node labels, and on the node labels, the zone is there. And then the scheduler will use that to place your Kafka brokers or whatever that important workload that you have across the 3 availability zones. If you don't, if you look at the purple workloads and the green workloads, it just schedules it based on availability and other factors. It may not necessarily spread it evenly, right? So very important for your important workloads, you want to use this. Now, there are other gotchas that you have to be to think about, right? So if you do this, and let's say your important workload is backed by a persistent volume, when one of the, let's say there's an outage in your availability zone or some issue like that, and that workload cannot be scheduled there, the issue is, if you use block storage like EBS, you won't be able to get it up and running on one of the other availability zones because that block storage is tied to that availability zone. So maybe like some stateful sets will work with like a distributed file storage, but if you're using block storage, you have this kind of limitation. Something to keep in mind. Right. Anybody aware of the cross zone? Yes. This is a bit of a gotcha. So now if I now the AWS, does anybody know how much AWS charge per gigabyte for cross-zone traffic? It's actually 1 cent, but why did I say 2 per gigabyte? 2 cents per gigabyte. Anybody know? Huh? No. So actually, it charges when you go out of a zone and when it comes into a zone. So every gigabyte that goes, it will get charged twice. Now, this might not be a significant cost for some customers and some workloads, but this can actually be a significant cost if you have a very, a lot of data transfers between so if you have a very busy Kafka broker, so if you do a little bit of digging on Google, you'll see Reddit posts and articles where people have talked about like trying to reduce the cost, the cross-zone network traffic, right? So yeah, you have, like a Postgres cluster or a Redis, like a Kafka cluster that does a lot of replication. For example, let's say you write one message into the broker, and like you said, replication. So it goes into two different zones if you have spread it, right? So it gives you high availability and extra reliability, but it's going to cost you. And for some customers, this can be significant. And then you also have other microservices talking back and forth as well, right? So something to think about. And there's also latency, right? So I haven't found any of you know if there's an official sort of like an SLA given by AWS. I couldn't find anywhere that says this is the SLA between zones. But what I've noticed and what I've found out is that it's less than 10 milliseconds, right? About some people say 3, some people say 5. But there is going to be some latency as well. So why does that matter? Right. Let's say you have like a microservice, because these days it's pretty common, right? So organizations have 15, 20, 30, 50, 60. I've seen 100 microservices more. If one microservice talks to another microservice, so let's say this one in the blue gets a request, but it needs to talk to like 3, 4 other microservices to fulfill that request because doing some sort of integration talk. Now, for that one call, it hops across these availability zones to grab that data, right? And there's obviously the cost factor, which I talked about, but there's also the latency factor, right? And now, the 3 milliseconds may not be a big deal, but if you're doing a couple of calls, and they all can add up, especially if you're doing it one after the other sequentially, it can add up to a point that it might exceed the SLA you've given to your end customers, right? So there is latency, something to think about. And in order to avoid that, you could potentially look at, usually there are common microservices like that can act as a group. If there is a possibility, you could try and figure out using label selectors to schedule them all on the same pod, right? There are also topology-aware routing and stuff like that. That's a little bit out of my sort of area of expertise, but those are other things to consider, because otherwise, if let's say you have a Kubernetes cluster, the EKS cluster that's on a single availability zone, and then you end up migrating for high availability, you spread it across 3 availability zones. Now, all of a sudden, your cost might go up, and there can be latency issues, so something to kind of think about, right? So these are some of the considerations you'll have to think about when you go for a model like this. All right, so let's go to this. So I want to talk a little bit about this one. And in this case, this is the model we sort of talked about, right? When you're building a highly available cluster. But what about alternatives, right? What about you build a Kubernetes cluster on a single availability zone, but instead of one cluster, now you have 2 or 3 clusters where each cluster is on its own availability zone, right? There are pros and cons, so we'll talk about it. Now, there are some complications that I talked about, right? Cross-zone chatter, cross-zone cost, all of that, which is not here because everything is within the same zone. So, your latency is going to be less, cost is going to be less, but it's 2 different clusters, right? Now, you may actually end up increasing your compute because when you do 2 clusters and deploy your full application stack, you may not need exactly the same amount of nodes here, but you might actually be using more compute in this model, right? What about vendor licensing? Because if you're doing like a per host licensing, because for your monitoring solution, or you have some sort of vendor licensing for some sort of a database solution, you may actually end up doubling your cost here because you have to deploy the exact same stack on the other one, right? So you may save some money here, you may save on the latency, but you may actually pay a higher cost over here. But for some customers, actually, this second model works better because their networking costs are actually significant. This also gives you more operational flexibility. Why? Because here, if something goes wrong in this cluster, it may actually affect the workloads. Here, if something goes wrong in one cluster A, cluster B is fine. So your blast radius is small, so you'll get higher availability. If you're doing upgrades, you can do, let's say this is the only cluster you have, it's going to have some downtime, right? This one. You can upgrade cluster A and then do cluster B. Canary deployments, blue-green, so you get a little bit more operational flexibility. There is one customer that I know, or rather one company that I know, runs upwards of 500, 600 Kubernetes clusters in production. And they actually prefer this model because this gives them more operational flexibility and less cost than this model. So it really depends on what you're trying to do. Then there's a third model over there that in this case, we're talking about across 2 different regions, and this I'm not going to go into detail because of time pressure, but there are cases where that model might serve you better. The only issue here is like data replication between the two, so you can't do like an active situation here, but it'll be like a DR, and you can potentially use this to serve customers in 2 different geographic regions and fall back from a DR perspective into the other one. So there's sort of different models to kind of think about, right? All right, so let's quickly talk about DR strategies. And in this case, I want to talk about this table. Actually, before that, does anybody know what an RPO and RTO is? There's a nice article on AWS. Yes. So, very quickly, RPO is how much data you can lose during an outage, or rather willing to lose, and how much, and RTO is how, what kind of a downtime you can tolerate, right? So this table, I've tried to put together sort of like a comparison between, your recovery times and cost, because the more highly available you're trying to do, the more cost you will incur. But based on your business and the kind of guarantees that you have given to your customer, it might be an acceptable thing. Very quickly, I will go through. So backup and restore is like the bare minimum that I think when you're doing a production-grade cluster. So things like Valero for backups, Terraform scripts, so that if your cluster goes up in smoke for some reason and you can't recover, you can quickly spin up another cluster, and then you can restore your data with Valero, and then you have GitOps, that can bring back your cluster state. I would still recommend using Valero for cluster state, even if you use GitOps. Why? Because sometimes we are all human. People forget to check things into Git. Couple of months ago, we had someone work for a whole sprint on some Grafana dashboards. We used the Grafana operator, so everything is CRD. Supposed to check that into Git. Person forgot. We did the new cluster, and suddenly 2 weeks worth of work is gone. And we've had other customers who are just using cluster state backup just as an insurance policy, because in case GitOps, someone has made a mistake and it's not there, right? And we're talking about RPO and RTO like a couple of hours with this kind of strategy. Pilot Light is like you keep a minimal workload running in another cluster. Usually the idea is that you replicate. Let's say you have a Kafka cluster and you can do like a Kafka mirror, so the data goes there. Some customers can lose data, so they use this strategy. There'll always be some messages that you will lose because replication takes time. The idea is that if there is a disaster, you quickly scale up from there, but there will be some time limit, right? Warm standby is that a fully functional environment, but with reduced capacity. Let's say your typical production cluster is like 10 nodes, but you run like something with 5 to 6 nodes with all your services with limited number of replicas, right? Let's say in production you're running like some workloads like 6, 7 replicas, but here you will run like, one or two. The idea is that when you cut off, everything is there and it will scale up, right? Hopefully you have cluster autoscaler or carpenters that can quickly scale them up. Final one is active-active and hot standbys. Active-active is pretty hard to do for most applications because of data synchronization challenges, but this is also probably the most expensive option because you have a fully functional environment sitting there, right? But for some government services, some financial institutions, they'll have to do this because business critical functions have to be up and running all the time. So this could be, in some cases, if you have if you have a hot standby, your global load balancers can cut over, and your customers will not even notice that you had an outage. So this gives that comparison between all this stuff. Let's quickly talk about cost. This is from the last CNCF report from SysDig. Lots of dollars wasted because developers over-provision. It's very typical to see. We also do a little bit of consulting on Kubernetes, and this is the number one pain, and that's one of the reasons why our product has a cost optimization pillar, because we find this to be a frequent common pain point. People over-provision. Usually, most applications, especially if they're Java, they're very memory bound, but pretty poor CPU utilization, right? So there's definitely some opportunities for cost optimization. And we also see this too. So when people see that, they panic and then they do aggressive limits. And then now you start to get the kills coming in because you've kind of gone overboard, right? And there's always some ramp up time when these things, so it can affect. So it's a fine balance between performance and cost. So something to kind of pay attention to when you're building a production-grade cluster. The other thing that a lot of customers kind of initially miss is that cost is reduced only when your nodes are downsized or reduced. So just because you optimize your workloads, if you don't have a strategy for reducing your nodes when you don't need during off-peak or low periods of activity, you're not going to save cost. Right? So, and then the other sort of question that people have is, should I do a smaller number of large VMs or a larger number of smaller VMs? It's an interesting question. So like I said, sometimes ramp-up time and other things are important. Some people like the smaller number of larger VMs because it gives a higher, a smaller blast radius. If one node goes, it's frequent actually, so sometimes nodes can crash and have issues, but it'll impact less number of applications. With a larger number of, with a large VM, there's more pods that are there, so if it goes down. So these are some of the interesting questions to look at and understand and experiment with. But here are some tips that I would leave you with. At the least, use cluster autoscaler, and that way you can scale your workloads, your nodes, up and down, and that can be a significant, a cost reduction strategy. And then, I asked about the smaller VMs versus larger VMs kind of thing. Packing the nodes with an optimal number of workloads. There's a project called Carpenter. It's started by someone from AWS. It's also now used on Azure. It's an open source project with some good support on AWS for it. What Carpenter does is, instead of us giving a static pool of nodes, Carpenter decides what's the optimal VM size for your workloads, right? So because with cluster autoscaler, when you start using it, you'll notice sometimes it scales up, but the last one or two nodes that it scales up, the utilization is low. You only have a few nodes on it, few pods on it. So, you're paying CPU and memory for and it's not being used, right? And it's costing you money. What Carpenter does is it looks at all your workloads and figures out what's the optimal number of nodes and what's the size. And you can tune it and say, these are the VM classes that we want to use and stuff like that. But it'll look at it, and if it sees a large VM that's pretty unutilized, it'll actually try to pack it into a smaller VM and get rid of that. And it's pretty fast too. There are a number of AWS workshops on this, pretty good documentation, so please look into that. And then another nice thing that I like about Carpenter from a security perspective, with Carpenter, you can define a TTL for auto rollover. So what it does is it'll recycle nodes for you automatically. And anytime a node gets recycled, it usually comes back with the latest patch. And then talking to some security folks, they like to recycle nodes, with a certain duration, because if you're running some sort of unwanted workloads or anything like that, if there's that's another way to sort of one sort of way to mitigate against it. But you also generally get like something with an updated AMI image, right? So it's a good strategy to have. So these are some of the things that we've sort of learned by running our own workloads and talking to our customers. Hopefully this was useful. And if you have any questions, feel free to, here's the event QR code. But I also encourage you to follow us on Twitter. We are going to do a series of talks with folks who are experts in Kubernetes and AWS. We're talking to people from networking side, security side, architecture side, and people who have run crazy workloads and stuff like that. And there's always some learning. So we will be posting them on our Twitter channel or X. Sorry, I should have said X, but yes, just we'll drop it there. All right, I think we are out of time, right on time. So first time I really timed something. Thank you very much for your attention and listening in. I really appreciate it. Maybe if there's one question, 2 minutes,
yeah.
yes?
Thank you,
okay.
Rajith. Yeah. Just one question here is, when is Kubernetes the wrong choice in the use cases that you described?
Oh, so, okay, that's a great question. I think Kubernetes does come with some complexity. A couple of years ago, where the cloud vendors didn't have a managed Kubernetes service, I think it was difficult to run it's a massive operational overhead and burden. But with all the cloud vendors supporting managed Kubernetes offering, that has been reduced quite a bit, right? But that also means even with that, there is some knowledge that's required. So at least, especially if you're a startup, there are other potential things like Fargate, Google has Cloud Runner, things that might perhaps cost you more initially, but less operational overhead. Somebody asked me that question at the booth as well. But as you grow, Kubernetes can give you a lot of flexibility, and some of the very highly scalable workloads that I know is using Kubernetes. So it really depends on, can you absorb that complexity and then have some sort of knowledge. So it has to warrant the overhead of running Kubernetes versus the actual cost benefits for you. Yes.
Okay.
Yeah.
Thank you, Rajith.
Sure. My pleasure. Thank you so much.